Hello guys and welcome back. So this is a shape that we see in Gothic architecture a lot, and I'm not gonna waste a lot of time looking at references. I'm gonna dive right into it and show you what the problem is and how we're gonna design a solution for it. So basically we want to create a system. We want to create a system that allows us to generate this shape, and then we can loft anything on it. So for example, here I'm lofting this geometry, this profile, in this case it's this profile, but look at the blend between these different shapes. If we were to have a profile that is connected all the way through and then we just skin it, it's going to have a lot of issues in this area. It's not going to be able to give us a nice edge, a nice seam there. Same goes here. You can see here it's a version with five repetitions. We can make it with three. It's this one, I believe, and then this is a different design. So let's see. Yeah, and this one is it's a different version, but it's based off of the same system. So that's another iteration, and we can do pretty much any. This is also created off the system, and it can create all kinds of complex profiles. Now the main trick, apart from the profile, the main trick is getting this edge here, which will be a separate problem that we're going to tackle later. So what we need is a way to input a simple geometry that tells this system that we have four circles. For example, in this case we would use a grid, and that grid has 4 points, and then those points will get converted into these shapes. Okay, and then let's say if we have 3 circles, 3 corners only, we would start with a triangle. Okay, we'll start with triangle and then copy circles to get these shapes, and then the intersection between these circles would give us the shape that we want. But if we let me draw for a second. If we think about it, all these are basically either a triangle or a rectangle or a hexagon or an octagon. It's a solid geometry that has a flat face. Okay, so for example, if it's triangle, it would be something like this. Sorry, I'm not the best person when it comes to the Wacom tablet. So let's say this is a triangle and we want to create these circles. Well, if we can find a way to convert this guy into a circle like this, and like this, and like this, and delete all of this, we will be able to get this shape. Okay, then if we change the triangle to be a hexagon or any shape we want, we can take each of these guys and convert them into circles or an arc, and then blend that arc. And that's what we're going to do. We need to be able to start with a simple geometry and convert any flat spline or edge into a circle. So that's going to be our first problem. And then once we have that, we're going to move on to solving other problems. So let's get started. This is the scene file. I'm going to start with a circle. And the cool thing about the circle is you can set it to 3, and it will give you a triangle, and it's iso, so all the faces are equal as a 60, 60, and 60 angle. And what I need is we need these guys separated. So I just need an edge or a primitive, basically. So let's do that. We're going to use a carve to convert this into an open geometry. I'm going to set this to 0. And then if we take a look here, it still says 1 primitive. Okay, all this is a single primitive. You can see by selecting it, it's hollow. There is no geometry, but it's a single primitive. I want that to be 3 primitives, so 0, 1, 2. That's the order. We're going to use a second curve. And with this one, we're going to set it to 0. And the second U, we're going to set it to 1. And if we take a look, it's still primitive. The number of primitives is still 1. What we need to do is we need to go under breakpoints, cut at all internal U breakpoints. And that's going to give us separate primitives. You can see now I can select them. Versus here, I cannot. Versus this part, I cannot do that. Cool, so we have a good starting point. Now we're not going to solve the problem for all of them at once. We're going to just focus on one. So I'm going to select it, hit delete, and remove that. And I'm going to resample it. I want to add a lot of points. I'm going to resample it to 100 points. And we have 101, that's fine. And we can see the point numbers starting from 0 to 100. Cool. So let's see, let's create the first most important attribute that we need. We can do this through the curve view attribute, but I want to show you a way, I think we've done this already, that you don't have to use a resample to compute this. We can use a texture node, a UV texture node, change it to arc spline, change this to point, and then we have a UV coordinate that has the parametric information. And the UV.x represents that value that we need. And from this we can create a linear value that interpolates, and I will show why we're going to need that. So if I display a ramp, or yeah, that's good. I can do that. So we'll display it later. Okay, let me check something super quick. Okay, so the idea that I want is, let's say we have this guy. How are we going to convert this into a circle? Okay, well we can hand place a circle. Let's look at the top. And this is what we need. We need a circle that starts here and ends all the way. And I want to be able to, whenever I scale it, let's say this is the size of the arc. Okay, I want this end bit of the circle to always end here, no matter what. Okay, so we need to scale it down and position it properly. And if we change this size, the arc, let's say something like this, we need to scale it down, scale it up to always be equal to the length of this. Okay, so let's forget about this for a second. What I want to do now is, actually, let's not forget about this. We want to explain the idea. I want to take the point number 0, or a point from here, that is the base of this curve, and in this case we're starting at 0, so we're going to delete everything except that point. We're going to use a blast. We know that the first point is always called 0, so delete non-selected, and I have my circle. I have the point, so I'm going to copy the circle. That. So the circle is now, let me change it to polygon, and let's increase the division, and let's change it to an open circle so we know the orientation. Okay, so now the circle is moved to this point, but I don't want it to be based off the center. I want it to be based off point 50. Okay, instead of the center being the origin, I want it to be point 50. Well, we can do it by hand. We can take point 50 and move it like that. But I want to do it programmatically. I want to make a system that moves all the points so that the 0 is always at the origin. Okay, well, how can we do this? Well, if we take a look, I'm drawing with the mouse, sorry, it's not going to be better. Sure, they have shapes. Okay. Not much better. Never mind. I'm gonna use the pencil, and unfortunately it's gonna be an ugly circle. So let's say come on. Sorry about that. Let me pause for a second. So if we take a look at what we have a grid at 0, and then we have the circle like this. Okay, this is point number 0. And what I want to do is we can take this distance that is the P position, the position of point 0, and apply that offset back to every single point, and that will move point 0 back to the origin, and this point to the correct location, and this and this and this, and it will center everything so that it's always point 0 is always at the center and the circle is correct. So let's do that. Okay, let's create a point vol. Let's dive inside. And I want to import the position of this point. You can see now it's 0, 0 here. I want to import that position. How can we do that? Well, we use an import point attribute. Okay, I'm going to tell it to use the first input, that's our geometry. We want to import the attribute named P, and the point number is 0. So let's create a constant, and it needs to be an integer. You can see here it's blue and it has an int type. So we're gonna connect that, and the default value is 0. If we want to import point number 1, we can change this to 1. If we want to import number 50, change this to 50. So let's set all the points, override all the points. So everything now is stuck at 50. But we don't want that. We want to keep everything, and we want to move them by this offset, which is the position of point 0 from the distance. Let's do an add. Actually, we need to subtract. So let's subtract all the positions. Subtract this distance from all the points. And now we moved it to there. Well, why did I do that? If we go back and change the division now, you can see it's always there. It's always at the origin. If we change this, look at that. And this is very, 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 very important. Okay, if we change this, it's also going to be correct. Cool, so let's take a look and see what happened. There's a viewport display issue. It's showing a copy. Don't worry about that. Yeah, sometimes it happens very often, actually. So the easiest way is to close the viewport. Okay, so this is the circle copied. And this is our curve. Well, we need to do a few more things. We want the circle, this section here, this opening, we want it to be always oriented to this guy. Always the same orientation. And right now, it looks like the circle is flipped the other way. So let's add a mirror and just flip the result. Okay, let's take a look at this. I'm going to turn off keep original, and let's find the axis. X didn't, Z didn't work, X didn't work. Let's try. Sorry, X didn't work. Yeah, X worked. I think it's working, something like that. Let's take a look. Okay, and now let's say we have this angle here, this distance. We want that to be aligned with this vector. We want the circle to be always aligned so that the point 0 is here and the point X, the end, is here. Now how do we do that? Well, we need an orientation vector. We need to compute the orientation for this. Well, it's actually very easy. We can do that using a polyframe node, because that will give us the tangent. Let me move this here. Let's plug the tangent into n and take a look. Okay, so now we have a vector following this. Okay, let's take a look. And let's template the curve, and we want them to be aligned. So let me play with this. Yeah, I think this is working. So I had to flip it in the Z direction, and now it's properly aligned. We just need to clip everything beyond this point from the circle. Okay, so let's do that. We have this extra bit. I'm gonna clip it. So I'm gonna do clip here, and it's facing the, let's see what direction, it's facing the X axis, and delete not selected. So now we should have, we should have a circle clipped at this orientation, at this line here, and starting at point 0. The only thing we need is we need to change it so that this distance is always equal to this curve. Okay? Well, we need few things. We need to know the distance, the length of this curve. Okay? So let's compute that. We can use a measure tool. Yeah, we need to do it here before we blast. And the measure tool can compute the parameter of the input geometry, and it's going to create that attribute called parameter as a primitive attribute. So it says 9.526. I want to verify this using point_vop. So let me copy this. I'll explain why in a second. And I want to compute the distance between point 0 and point the last point, so point 101. Okay, so we're already importing point 0 in this graph. We just need to import the last point. Let me copy this, and it's point number 100. That's its ID. I'm going to subtract the 2, and that's going to give us a vector also following the direction of the curve, which we can use. But instead I'm going to compute the length, and that's going to tell me how far apart these points are. Let's connect that to the color and take a look. So it's 9.52, and here it's 9.52, so it's the same value. We're good. And it's a primitive attribute right now, and I want to change that. I want it to be a point attribute, but first let me change its name to be called length, and I'm going to promote it, and this allows us to change the class of an attribute from anything from a point primitive detail to something else. And we're going to say from primitive to point. The mode in this case it doesn't matter because there is nothing to average it with, so it's going to be fine. We can say first match or minimum first match works as well. You can see now we have a length attribute. What we want now, we want this guy here to be equal to that length so that when we copy it, it matches. So let's do this. Let's also compute the length of this attribute. Well, how are we going to do that? The perimeter attribute is going to give us all this, but we don't care about that. We just care about this distance. Well, we just did it here. So let's reuse that. Okay. Sorry, checking something. So what we need is we need to subtract the distance between these two guys to get the vector, to know how to get the vector, and then compute the length to know how far apart they are from each other. But here we're importing the second point, and in this case it could be 35, it could be 100, could be 1,000, we don't know. But we know the number of points. Okay, we know how much points we have in this curve, and it's generally the point number is that number minus 1, the total count minus 1, because the point attribute number starts at 0. So all we have to do is subtract 1 from the number of points, and that gives us the correct value for the points that we're interested in. Let's call this start point, or start point, and this is going to be the end point. And let's connect this guy, and now we're subtracting this from this, and we're getting the length of that. So let's take a look. We're plugging it into the color, so it doesn't matter, and it's 11.5, so it's quite far away, far off from what we have here. Okay, and what we need to do is we need to shrink this to 1. We need to resize it to 1 all the time. We want this guy to be 1. So how do we do that? Well, we can do this. We can use a transform matrix, and don't worry about the name doesn't mean anything. We're gonna take the points, all the points, and we can scale them. Think of this as a scale tool. Okay, so I can use this scale, rotate. It's same as a transform node, it's the same thing, and the pivot is 0, 0, which is fine, so we can scale it up or down. Okay, we know the length of this. Okay, so if we take this, if we take 1 and divide it by the length, it will give us a ratio. And then we use that ratio with the scale. It will either scale it down or up to match the difference of that ratio. So let me do it, and it will become more clear. We have the length of this. We're going to take 1. So I'm going to create a constant and divide this constant by this length. And then plug this result here. Let me turn off this guy. And now it's going to be, you see it's already 1, a value of 1. It's just because of this mirror, which we can do later. So let's take a look. See, it's 0 to 1. Okay, and let's move that clip that we had. Why is the clip not working? 1 second. I know why it's not working. So the reason it's not working is because we need to let me check. The reason for this, I believe, is the point count is changing between the clips. If we take a look at the result from the clip and take a look at the point count, the point number, it's changing. Okay, we want that to always be static. Well, we're going to do that using a resample node. So I'm going to turn this off, and turn on the maximum segments and set this to 100. No matter what the shape or size of this, it's going to be always 100. Okay, then let me check. There was one more thing. Okay, let's try and copy it. I'm not so sure what is happening. I have to check with my original file and see what's the difference. Okay, I will I'll compare a few things with the file and then continue in the next video. Thank you guys for watching, and see you in a bit.